Bismillah Rahman Rahim. Assalamu alaikum. Welcome to ASTC. This is Cambridge IGCSE Mathematics 0580. So today we will be working through February March 2025 paper 42. So let's get started. All right. Write down a factor of 28 that is a prime number. Okay, so we need to write down a factor of 28 and that factor should be a prime number. So when we are writing down the factors, we can write it in this way. So let's say that if we start with 1, so we have 1 times 28. The next is 2, so 2 times 14. Then we don't have 28 in 3's table, we have it in 4's table then. 4 times 7. And that's it. These are the only factors of 28. So from here you can identify that there are two factors which are prime number. It could be either 2 or it could be 7. So you're supposed to write only one, so you can write either one of them. So you can write either 2 or you can write 7. Question number 2, simplify 4y squared plus 3y minus y squared plus 2y. Now, here we have a combination of terms, right? So we have term in y square and we also have term in y. The first step to do here is to collect the like terms. So we can write 4y square and then next to it we can write minus y square. After that we can write plus 3y and next to it we can write plus 2y. Now we have collected like terms on together. Okay, so now we can simplify them. So 4y square minus y square, that will be 3y square, plus 3y plus 2y, that will be 5y. So that's your answer. Now this is up to you. If you want, you can take it one more step further. You can factorize y and you can write it as 3y plus 5. But if you leave your answer in this form, that is perfectly fine because the question does not ask you to factorize it, right? So you can leave your answer in this form as well. All right. Question number 3. Shade two more small squares to make a pattern with two lines of symmetry. Okay. Now, if you want two lines of symmetry, okay, in a square, we can have four lines of symmetry. Okay, we can have a line over here, we can have a line over here, we can have a line as a diagonal, and we can have a line as another diagonal. So we need to shade the squares in a way that we should only have two lines of symmetry. Okay, now if you look over here, the center of this would be from here, a line from here to here. Okay, so if let's say that I want to split them, if I want to make the line of symmetry in this form, then for this purpose, first of all, this box should be shaded. Okay, and secondly, this box should be shaded as well, right? So you can say that okay, in this way we can have one line of symmetry. All right, but we need to have two lines, right? So let's say if I want to now make a line of symmetry over here, so now there's going to be a problem because you have three boxes shaded over here, okay, and they do not overlap in this case. All right, so we cannot have this line of symmetry. All right, so if we try something else, let's say if I want a line of symmetry diagonally, so for this purpose you need to shade this box as well, but you cannot shade three boxes. It only asks you to shade two more small squares, right? But now notice that if I were to draw a line of symmetry from here to here, okay, and if let's say that I do not draw this one, if I let's say I do not shade this one, then it can give you two lines of symmetry perfectly. So what I mean by that is, let me mm, redraw it so that you can see clearly. If let's say that I shade these two boxes, okay, and now I draw my line of symmetry from here to here, the diagonal. Sorry, just a minute. Like this, that's one line of symmetry, and you can see that they perfectly overlap. If you fold them in this form, then they perfectly overlap. So that is one line of symmetry. And if I draw a line of symmetry, which is the second diagonal of this square, so that will also give you a perfect symmetry. Now, definitely you'll be using a ruler for this, right? So I don't have this facility over here. But anyhow, now if you can see that if I were to draw a line of symmetry from here, and if you overlap this on this side, then again you can see that they do overlap, right? So that's why the two small boxes that should be shaded will be this. Now you're not required to draw two lines of symmetry, but to help you, you can draw it with pencil. Do not draw with pen. All right. Question number 4. Calculate 20.24 minus cube root 30 over 6.5. Calculate means that you are supposed to use a calculator for this purpose, and then it says give your answer correct to one decimal place. Now the question is, why is it for 2 marks? I mean, this is just a straightforward question, right? Now the trick here is you're supposed to give your answer in a greater degree of accuracy than one decimal place, and then show that okay, this is what we got. Now if I round this answer to one decimal place, then that's what I'm going to get. So first of all, let us work out the value of this. So we have 20.24 minus cube root of 30 divided by 6.5. So here the answer that I'm getting is 20.24 minus cube root of 30 over 6.5 gives us 2.63581, and so on. Now if I round this to one decimal place, so I'm going to get 2.6 to one decimal place. All right, so therefore my answer will be 2.6. Had you written only 2.6, you would have lost 1 mark, because 2.6, that should be shown that later on if you are to round it off, that's what you're going to get. So remember, and that's not only for this type of question. Every question that requires your answer to be in a particular form of accuracy, in a particular degree of accuracy, then that means that first you have to show some greater digits, and then you have to round it off according to what they have asked you. So if let's say the question was that give your answer to 2SF, so you will give your answer to 4SF and then show that the rounding will give you 2SF. All right. All right. Question number 5. A pattern is formed by three congruent rectangles. Each rectangle is a rotation of 90 degrees around one vertex of the rectangle next to it. Okay. The point A has coordinates 2, 5. So this is point A. The point B has coordinates 4, 1.5. This is your coordinate of B. Now the question is, work out the coordinates of point C and D. All right. Now it says that these are three congruent rectangles. All right. That means that they are identical to each other. Their dimensions and their angles are exactly the same as compared with each other. So if I work out the dimensions of the rectangle, so we can see that the the x value of A, that is 2. The x value of B is 4. So that means the length or the difference between the x coordinates of A and B will give us the length of the rectangle. So this should be 2. 4 minus 2, that will be the length of the rectangle. All right, what about the height of the rectangle or the width of the rectangle? So, I mean, we can say that this is the width and this is the length. It's not really a problem. Okay, so you can go with anything. So let's say that this is the width of the rectangle because this is a shorter side, and because this is the longer side of rectangle, we'll call this the length. Now, if I want to work out what the length of this rectangle is, I can work out the difference of y coordinates of these 2 points. So 5 minus 1.5. So here I can write down 4 minus 2 is equal to 2, and 5 minus 1.5 equals 3.5. So this should be 3.5. Okay, and this should also be 2, and this should also be 3.5. Okay, now if I want to find the x coordinate of C, so that would mean that I have to move from this point. I have to move some units to the right in direction of x. Okay, now remember what it said, that each of these rectangles are congruent and they have been rotated 90 degrees. So you had this rectangle, then you rotated it 90 degrees, and this is what you get. When you rotate this to another 90 degree, this is what you get. So if this is 3.5, that means that this should also be 3.5. Okay, and this part of the rectangle should be 2. Okay, so therefore the difference between them should be 1.5. Okay, and similarly this should also be 2. All right, now if I want to move towards C, so starting from B, how many units do I have to move towards C in x direction? That should be 7.5 units. Okay, so I'm going to write here x coordinate of C equals, so that will be 4 plus 3.5, that is equal to 7. Now y coordinate of C, so if I want to work out the y coordinate, so this is 1.5, this part of the rectangle is 1.5, right? So that gives you the same height as C. So that means it will be 1.5 plus this 1.5, that is equal to 3. Well, let me just plug in my charger. All right, now let's try to work out. So okay, so basically that gives us the coordinate of C. Sorry, this is 7.5. So 7.5 comma 3. All right, okay, that's the first one. Now we need to work out, let me write this down here, 7.5 and 3. Now similarly, just like how we labeled here, we'll do the same thing here. This is the length of the rectangle, which is 3.5. This is 2, this is 2, and this part will be 1.5. Now for C, if I want to work out the x coordinate, so I just have to add 2 into it. So x coordinate of D equals 7.5 plus 2, which is equal to 9.5, and then y coordinate of D is, so here we have 3 and I have to add 3.5, so I'm going to get 6.5. So therefore this will be 9.5 comma 6.5. Okay, question number 6. Each week, Nisha is paid $12 per hour for the first 40 hours that she works. She is paid 30% more per hour for any extra hours that she works. Okay. So if there are more hours than 40, so that for those particular hours, she's going to get 30% more per hour. One week, Nisha works for 45.5 hours. Calculate how much she is paid that week. Okay. So if let's say if the hours exceed 40 hours, right? So what will be the hourly rate at that time? So like the normal hourly rate is $12. So per hour she gets $12, but after 40 hours of work, any hour that is extra, right? So that should be 30% more. So 30% more basically means 130% of 12. So that is 130 divided by 100 multiplied by 12. So that should be $15.6. All right, this is the hourly rate for extra hours. All right, so now she works for 45.5 hours. So the total pay would be, for the first 40 hours, there will be 12 times 40 plus. Then for the extra 5.5 hours, which is the difference between 45.5 and 40. So that should be 5.5 hours. Let me first write the hourly rate, which is 15.6 multiplied by 5.5. Okay. So 12 times 40, that is 480 plus, let me work this out, 15.6 into 5.5, that will be 85.8 plus 480. So that gives us $565.8. All right. Number 7. The table shows the age and mass of each of 10 babies. Okay. So here you have been given the data. Complete the scatter diagram. The first 6 plots have been plotted for you. Okay. Let's see. So the next point, so the first 6 points are already plotted on the diagram. So you need to plot the remaining 4 plots. So let's see, we have age 9 and the mass will be 4.6. Okay, age is on the x-axis, mass is on the y-axis. So this is 9 and then we have 4.6. So that's 3, that's 4. All right. So first of all, you need to work out that what is the scale on each of the axes. Okay, so if you're unsure, let's just say, so the best way to do this is, let's say that between 4 and 5, how many boxes can we see? These are 10 boxes. So 10 boxes, they represent one unit, right? Because 5 and 4, between 5 and 4, that is one unit. All right. So how much does one box represent? That'll be x. So x should be, you cross multiply them. So that will be 1 upon 10, which is 0.1. So that means every small box represents 0.1 unit. Okay. Similarly, over here we can see that between 1 and 2 there are 5 boxes. So 5 boxes represent 1 unit. What does one box represent? That will be x. So again, here you have 5x equals to 1. So therefore, x is equal to 1 upon 5, which is 0.2 unit. That means each box represents 0.2 units. So if I'm going to start counting from here, there will be 1.2, 1.4, 1.6, 1.8, and 2. Whereas on the y-axis, each box will be 1.1, 1.2, 1.3, 1.4, 1.5, and so on. Okay, so the first one was 9 and 4.6. So this is 9 and this is 4, right? Now 4.1, 2, 3, 4, 5, and 6. So over here. So we have to make a cross. You have to mark a cross over here. The next one is 7, 4.5. Okay, so this is 7. 4.5 is over here, exactly between 4 and 5. Okay, then 1, 2.5. Okay, 1 is over here, and 2.5 will be at the center of 3 and 2. Then we have 11, 5.3. Okay, 11 is over here, and 5 is over here, so 5.1, 2, and 3. All right, so this is how we have completed the scatter diagram. We don't have to draw the line yet. Now the question is, what type of correlation is shown in the scatter diagram? Now when it asks you the correlation and the number of marks are only 1, so basically they're asking you that, is it a positive correlation, is it a negative correlation, or is there no correlation? They're not asking you about strong or weak correlations. Okay, so we can see that as the age increases, the mass also increases. So when both the variables they increase, so that is a positive correlation. On the scatter diagram, draw a line of best fit. Okay, so now for this purpose, let me take a screenshot. Okay, so now we have to draw a line of best fit. Okay, what exactly do we mean by line of best fit? Let's first understand that. Now, you cannot draw a straight line that can pass through all of these points, right? So you're going to try your best that your straight line, okay, which is the line of best fit, should be as close as possible to as many points as possible. Let me repeat that. Your line of best fit should be as close as possible to as many points as possible. Okay, so let me draw it over here. So I'm going to see that which straight line can pass through or at least be closer to most of the points. So if I draw a line over here, so that should be good enough. Okay, so that's my straight line. So it does not pass through all of them, but the distance between different points and the line, that's not too much, except for this one. All right, because this one is quite far. Maybe it's an anomalous point, we don't know that. Okay, but this is the straight line of best fit, and it must be drawn with a ruler. All right, now it says use your line of best fit to find an estimate of the mass of a 14-week-old baby. So 14 is over here, so let me use my ruler to help me. All right, if I keep my ruler over here, now 40 should be over here. Okay, this is the mark. All right, now what I'm going to do is, now keep your ruler like this and draw a dotted line from your mark all the way till y-axis. Okay, Now you can read off the value from y-axis. So we can see that our value is going to be 6.2, right? So that will be 6.2 kg. So this is mass, okay, on y-axis. So our value will be 6.2 kg. All right. So that's your answer. So you can take a look at the diagram again. And it's better if you also draw. Yeah, I think I forgot to do this. It's better to draw this vertical line as well. The line that goes, oops, the line that goes all the way to 14. Because basically here what you have to do is you have to show how you got the value. So first of all, I put my ruler at 14, drew a vertical line, then I see where it touches the graph, and then draw a horizontal line from there to y-axis. Okay, so that was the end of question number 7. Question number 8. The scale drawing shows the positions of boat A and boat B. The scale is 1 centimeter. The scale is 1 centimeter represents 0.5 kilometers. Okay, so you have 2 points A and B. So basically these points, they represent boats. Find the actual distance between boat A and boat B. Okay, now for this particular question, you're supposed or you're required to use a ruler, okay, and possibly in the next part you're required to use a compass. So now what you can do here is, if you use a ruler to measure these 2 points, okay, so now for this purpose, because I'm doing it digitally, so that's not possible for me. So what I'm going to do is I'm going to show you what we can get from the marking scheme. Okay, this is question number 8. So let's see. All right, so here you should get 4.2 centimeters. So when you use your ruler to measure the distance between A and B, so that should be 4.2 centimeters. Now you need to find the actual distance. So then you have to use the scale. So if 1 centimeter gives us zero point 0.5 kilometers, that means 4.2 centimeters will give us x. You can cross multiply them. So that will be 4.2 times 0.5, which is 2.1 kilometers. That will be the actual distance according to the given scale. Okay. Now, in part B, it says lighthouse L lies to the east of boats A and B. Okay, so east is over here. So that means L should be somewhere around here to the right hand side of A and B. L is 4.4 kilometers from boat A, so 4.4 kilometers from A and 3.3 kilometers from boat B. Using a ruler and compasses only, construct and label the position of L. All right, so it is 4.4 kilometers to the right somewhere over here, right? But we cannot draw just a straight line like over here. On the east means it is somewhere around here. Okay, now this type of question, or let us first write down what dimensions do we have. We know that AB is 2.1 kilometers. We know that AL, which is the distance between A and lighthouse, that is 4.4 kilometers. And the distance between both B and L is 3.3 kilometers. Okay, now what we're going to do here is, if I want to mark the position over here, so I have to convert them into centimeters first. Okay, so this one is 4.2 centimeters, double of this. This one should be 8.8 centimeters, and this one should be 6.6 centimeters. Okay, because I'm marking over here, right? So I have to convert them back using the same scale. I have to convert them back into centimeters. Now what we're going to do is, if you have done questions which are of the type that you have to construct a triangle and all three sides are given to you. So you use a compass to do that, right? This is exactly the same question. You put your compass at point A and you open it to about 8.8 centimeters. Okay, so let's say that when you open it to 8.8 centimeters, you make an arc over here. Okay, now you have to put your compass at B and open it until 6.6 centimeters. Then you have to make another arc and that goes from here. So for example, it goes over here. So now this is the point where the arc from A and the arc from B intersect. This is your point L. Okay, so that's it. You don't have to draw all straight lines because it only asks you to construct and label the position of L. That's it. So make sure that you leave your construction arcs because that is part of your working. Okay, and make sure that the distance between AL is 8.8 centimeters and the distance between BL is 6.6 centimeters. So that's how you're going to do it. Okay, question number 9. Write 0.00709 in standard form. Okay, so if I want to write this in standard form, so let me write this over here. So I'm going to move the decimal place to the right. Okay, now in standard form, if let's say that I have a times 10 to the power of n, where n could be any number, make sure that you understand this, that a is greater than or equal to 1 but less than 9. All right, this is the standard notation that we use, or let's say this is the rule that we use for standard form. If you want to write your answer in standard form, your a should be between 1 and 9, where it can be sorry, this should be 10, right? Between 1 and 10, where 10 is not inclusive. So that means your whole number value will be 1 point. I mean, it could be any number between 1 and 10, where 10 is not included. So it could go from let's say 1 all the way until 9.9. All right. Okay, so now we are going to move this decimal point from here to one place to the right, another place to the right, and a third place to the right. So therefore this becomes 7.09 into 10 to the power minus 3. Okay, part B, work out 4 into 10 to the power of 4 whole square. Okay, now remember that if you have a power outside the bracket and a power inside the bracket, so here the power of 4 is 1, the power of 10 is 4. So these powers they will multiply. So this becomes 4 square and this becomes 10 to the power 4 times 2. So this will be 16 into 10 to the power of 8. Now, if you look over here, this is not in standard form because I just mentioned that your A should be less than 10. Okay, so that means this 1.6 can be written as, 16 can be written as 1.6 into 10 multiplied by 10 to the power of 8. Now the bases are the same, right? So these powers can add up. So therefore your final answer should be 1.6 into 10 to the power of 9. So the power of 10 is 1 and the power of 10 over here is 8. So using the rules of indices, we have the same base, so the powers can add up because they are being multiplied. So this will be 1.6 into 10 to the power 9. All right. Question number 10. Draw the image of triangle A after a reflection in the line y equals to 1. Okay, so y equals to 1, this is your mirror line. Okay, so let me draw a straight line first. Now the mirror line is always drawn as dashed line. Okay, this is your y equals to 1. If I want to reflect it in this line, now remember that the distance between the object and the image from the mirror line is exactly the same. So if I were to work out that what will be the position of triangle A after reflection, so let's say I pick this point. The distance from this point to the mirror line is 1 unit. So from the mirror line to my image should also be 1 unit. So this point will reflect over here. This point from the mirror line is 2 units. So again, from here, it should be 2 units. 1, 2. This point is 1, 2, 3, 4 units. So again, 1, 2, 3, and 4 units. So now we can join these points. All right. Okay. Then it says triangle A after a translation by the vector -6 and 1. So this is a column vector, and the top part of the column vector represents that how many units do I have to move in x direction. Sorry. And the bottom point tells you about how many units I have to move in y direction. So if it says -6, that means that you have to move 6 units to the left. Minus tells you that you have to move to the left. So if I again pick one point, so let's say I've picked this point. Now I have to move 6 units to the left. So 1, 2, 3, 4, 5, 6. Now speaking of this, now look, because translation is just moving the vector, right? So if I've translated only one coordinate, okay, I can now just mimic that, okay, how the shape looks like. So it goes from here to here, so I can just draw it from here to here. Then for this one, okay, you can draw it over here like this, and then you can join these points. But it's still, if let's say you are still confused, you can do the same thing. So let's say if I take this point, for example, so take it 6 units to the left. One. Okay, sorry, just a minute. There was also one more point, right? 6 units to the left and 1 unit up, right? So I forgot that part. So that's where this point will be translated. Now here, from here you can continue. So you can draw this, then you can draw this line, and you can now draw this line. So again, if let's say you want to move this point, so first count 6 units to the left. So we have 1, 2, 3, 4, 5, 6, and then 1 unit up. So there you go. Okay, part B. Describe fully the single transformation that maps triangle A onto triangle B. So they have given you triangle B already, so you have to you have to show, or you have to explain that, okay, what transformation has been done here that maps triangle A onto triangle B. Okay, now there's a trick over here that you should understand. If the question is of 3 marks, okay, if the question is of 3 marks, that means it would be either rotation or enlargement. Okay, if the question is of 2 marks in describing, then that question would be about translation or about reflection. These are the only 4 transformations which are part of your syllabus. Now, because the question is of 3 marks, so we can say that, okay, this should be rotation or enlargement. We have narrowed it down. All right. But if you look at the size of the object, if you look at the size of the image, which is B, does it look like that there has been any change in its size? Because enlargement is either making an object bigger or making an object smaller. That's enlargement. So we see that there has been no change in the size of the image. So therefore we can now conclude that this should be rotation. Okay, that's point number one. Second point, once you have identified that this is rotation, you need to give two more details. You have to give the angle of rotation, okay, whether it is 90 degrees clockwise or it is 90 degrees anti-clockwise or it is 180 degrees. In 180 degrees, you don't mention clockwise or anti-clockwise because it doesn't really matter. If you move clockwise 180 degree or anti-clockwise, it is the same thing. That's the second thing you have to mention. Third thing that you have to mention here is the center of rotation. Okay, now from the shape itself, you can see that this point, okay, is actually this one. The corresponding point on triangle B is this point. The corresponding point of this point is this one. And the corresponding point of this is this one. So that means it has been rotated like this. So if you rotate it to the left, and how much you have to rotate, okay, you even have protector with you, so you can also measure it, right? So we can see that this has been 90 degrees rotation anti-clockwise. It is moving in this direction. Okay, so this is 90 degrees anti-clockwise. Now comes a tricky part, which is center of rotation. Now there are two ways that you can do this. Okay, so let me first copy this down. Okay, so there are two ways that you can do this. One of the methods require you to use a tracing paper. Okay, that is much easier method. Okay, that what you can do over there is you keep a tracing paper on top of your object. Okay, make the shape on top of the tracing paper and then try to rotate it at different points until you reach a point where you can exact where your drawn object is exactly mapped onto this position. At that point you can see that okay how you have rotated it. Okay, or you can see that from the at which particular point you have to rotate your tracing paper so that it maps onto this point. Okay, so that's the first method, and that's probably the easier method. It is actually the easier from what I'm going to tell you about the next method. The next method is about you have to draw some lines over here. So let's say that I've identified two corresponding points. Okay, so let me draw a line through these points. So I can draw a straight line from here to here. And secondly, let's say that I join the red points. Okay, now what we're going to do is for this green line, okay, we are going to draw its perpendicular bisector. And how we are going to do that? Using protractor, you have to measure that where does it become 90 degree. Okay, so just by estimation I'm going to say that okay 90 degree is going to be somewhere around here, right? So let me so I'm going to keep my compass over here and I'm going to make an arc. So let's say that arc is somewhere over here. Or okay, just give me a minute. Even drawing perpendicular bisector, there are two ways to do that. Okay, one of them requires a compass and the other doesn't require a compass. Now What you can do is, if let's say I want to draw the perpendicular bisector of this green line, first of all I need to find where its center is. Measure the line, okay, the length of the line, and then find its center. Okay, let's say that this is the center of this line. Fine. Now keep your protractor at 90 degrees over here. Okay, so your protractor should be kept in this form, like this. So the 90 part will be over here. 90 degrees will be here. Now that you have identified your center point on the line and your 90-degree mark, now you can draw a straight line. Okay, that is one way to draw a perpendicular bisector. A second way to draw a perpendicular bisector is that you open your compass long enough. Okay, open it like this, the space should be big enough. Keep the pointy part over here and then draw an arc over here. Okay, so you keep your compass over here, draw an arc over here, do the same thing from here. You have a second arc. So let's say that the arc that you're gonna get will be something like this. So wherever your arcs intersect, so you can just draw a straight line, okay, from here and all the way from to the center. Now that's the second way. Okay, now in the second way, you're not supposed to draw the second line right now. I'll tell you when to draw. First, what you have to do is, let me repeat it again in case if you got confused. First, put the pointy part over here and draw an arc. Put the pointy part over here, draw the second arc. That's it. Now move to the red line. Okay, on the red line, again, put the pointy part over here, make an arc, put the pointy part over here, make an arc. Now you have two sets of arcs. Let's say that was the first set of arc, and let's say this was the second set of arc. Now what you're going to do is, you're going to join these 2 points, the center of this arc and the center of this arc. When you draw them straight away, okay, wherever they intersect, that will be your that will be your center of rotation. Okay, all right, let me just clear all this up. Oh, sorry, I can't clear it up because it was taken as a screenshot. Anyhow, okay, let me repeat one more time. First of all, what I'm going to do is, I'm going to show you an easier way first, and then we can talk about the other way. The first one that I mentioned about was that you mark the center of this straight line. Okay, so for example, let's say that this is the center of this green line. Okay, and now this is at 90 degrees, so you can draw a straight line. All right, that's done. Now for the red line, I'm going to do the same thing. I'm going to find the center. First, I'll measure the red line, then I'll find the center, and I'll try to keep it at 90 degrees. So let's say that this is about 90 degrees, and now I'm going to draw a second straight line. Okay. Now, wherever these two straight lines intersect, that is your center of rotation. So here we can see they intersect at 3 minus 1. Okay. That is method 2. Method 1 was using the tracing paper that I already mentioned earlier. Now, method 3 is, let me clear this all up. So let's say that we put a ruler over here. Now, right now we haven't measured anything. Okay, so what we're going to do is, I've just put my pointer over here. I've just put my pointy part of the compass over here, and I just made an arc over here. So let's say this is my arc. Then I've put my pointy part over here, and I've made my second arc. Now using the same thing, okay, again my compass is at this point, and now I've made an arc over here. Then my compass is again at this point, at this point now, and I've made an arc over here. Join these two straight lines. Okay, so somewhat this is your perpendicular bisector for red line. Now do the same thing for green line. Put the pointy part over here, okay, and make an arc. So maybe it might be around here somewhere. Put the pointy part over here, make an arc over here. Do the same thing on the opposite side. Again, put your pointy part over here, make an arc over here. Put the pointy part over here, make an arc over here. Now you join these two straight lines. Now wherever they intersect, there will be a center. Now definitely, because this was not an accurate one, right? I just made an arc just to show you how the method works. So but if you do it exactly as I've mentioned now in detail, you're going to get your center at 3 minus 1 again. Okay, so I hope that this is clear. If let's say you're unclear about this, then just rewind the video to this point where I mentioned it more clearly. Okay. All right, so the center of rotation should turn out to be 3 minus 1. Question number 11. Midhill invests $1,500 at a rate of 4.2% per year compound interest. Calculate the value of the investment at the end of 5 years. Okay, so for compound interest, we will just use the formula I equals P times 1 plus R upon 100 to the power of n. So E is the compound interest, okay, P is the principal amount, which is 1500, times 1 plus R is the percentage. So that will be 4.2 over 100 to the power of n. N is the number of years. So if I work this out, that will be 1500 times 1 plus 4.2 over 100 to the power of 5. So that will be 1842.59. So we can round this to $1843. Okay. All right. Or we can actually just leave it in this form. That should be much better. Okay. Part B says Hitanshi invests some money at a rate of X% per year compound interest. At the end of 11 years, the value of the investment has doubled. Calculate the value of X. Okay. Now look, the question has changed a little bit, but it is still a question of compound interest, right? So I'm going to still write down the formula first. Now let's see. It says that it hasn't given you the principal amount. Okay, it hasn't given you that, okay, what was the exact value of the investment. But what we do know is that if he has invested P, then your value at the end should be double of P, so that will be 2P, right? And that'll be just P. 1 plus R is what we need to find, so that becomes X. Okay, because that is X% over 100, and n is 11. Now from here what we can do is this p cancels with this p. So that's why it becomes irrelevant whatever the value of p is. So now what we can do is we can take the 11th root, okay, because this is to the power of 11. If I take 11th root both sides, so this becomes 11th root of 12 equals 1 plus x upon 100. Now you need to find x, so this becomes 11th root of 2 minus 1 equals x upon 100. Multiply 100 to the other side, so 100 times 11th root of 2 minus 100, because this 100 is being multiplied with this as well as this. So therefore my final answer will be 100 times 11th root of 2 minus 100. So that will give me 6.50%. Okay. All right. Number 12. A cone has sloping edge 12 centimeters and base radius 5 centimeters. Calculate the total surface area of the cone. Okay, so the question is about the cone, right? So let me first make a quick sketch of it. The sloping edge basically means the slant height. Okay, so that is 12 centimeters, and this is also 12 centimeters. The base radius, that is 5 centimeters. Now it asks you to calculate the total surface area of the cone. Now you should see that the cone is made up of two parts. The first one is the curved surface area of the cone, right? The whole curved part. And the second one is the base, which is a circle. So there are two calculations that need to be done. So we'll say that total surface area is equal to area of circle plus curved surface area of the cone. Now both of these formula are given to you in the formula sheet. So this is the area of circle, which is pi r square, and the curved surface area of cone is pi r L. If you know them yourself, that's even better. But if in case you get stuck at any one of the formulas, so the formula sheet is already given to you. Okay, so pi r square plus pi r L. Now the radius of the circle, that will be 5 squared plus pi times 5 times 12. So this becomes 25 pi plus this becomes 60 pi. So this is 85 pi, and then we can work this out. So that is 85 into pi. That gives us 267 to 3SF. So 267 centimeters squared. Okay. The table shows the first 5 terms of sequences A, B, and C. So if we look at sequence A, okay, let's read the question first. Complete the table to show the nth term of each sequence. All right. Okay, so that's the only question. Okay, so here we have to see that first we need to identify what is the pattern between the terms. So sequence A is 5, then we have 12, then 31, then 68, then 129. So you can see that they're increasing at a quite fast rate. Okay. Now the sequences that we basically have can be categorized into 3 or 4 categories. You can have a linear sequence, also called arithmetic sequence. You can say the next one is a quadratic or a cubic sequence. Then we have geometric or exponential sequence. Okay, so these are the 3 types of sequences that you can have. Okay, for identifying linear and quadratic or cubic sequences, okay, what we do is, let's say that I'm going to write 5, then we have 12, 31, 68, 129. So I'm going to try to find that, okay, what is the difference between them? So the difference between 5 and 12, that is 7. The difference between 31 and 12, 31 minus 12, that is 19. The difference between 68 minus 31, that is 37. The difference between 129 minus 68. So that will be 61. You can see that this is what we call the first layer. I mean, I call it first layer. If the first layer is not constant, or let's say if the first layer is constant, okay, if you would have gotten the same value each time, we would have concluded that this is a linear or arithmetic sequence. Okay, but since that's not the case, now we move to the second layer. What is the second layer? That now you find the difference between these. So 19 minus 7, that will be 12. 37 minus 19, so that should be 18. And 61 minus 37, that should be 24. You can see that again in the second layer, if the difference would have been the same, okay, if I would have gotten the same value over here each time, then I would have concluded that this is a quadratic sequence. But since that is not the case, now I'm going to move next to the third layer. Now in the third layer, you can see 18 minus 12, that is 6. 24 minus 18, that is 6. Now in the third layer, this has become constant, right? Now we can conclude that this is a cubic sequence. So therefore, we can say that our nth term contains n cubed. So that's the first thing that we have identified. All right. N cube means if I substitute 1 into it, so I'm going to get 1, right? So let's write that down. So if the value of n is 1, then I'm going to get 1. If the value of n is 2, I should get 8. 3 cubed is 27. 4 cubed is 64. And 5 cubed is 125. Now, this is what I should get with n cubed. Let's compare this with the original sequence. Okay, the original sequence has 5, whereas I had 1. The original sequence has 12, I had 4. 31, 27, 68, 64, 129, 125. If you compare each one of these pairs, you can notice that there is a difference of 4 in each one of them. So if I just add 4 into it, if I say n cubed plus 4, I should get the sequence which is given in the question. Got it? So that's how you identify that the nth term will be n cubed plus 4. All right, so that was the first one. That was sequence A. Okay, sequence B is you have 10, 9, 8, 7, 6. Okay, in the numerator. Now when you have in fractions, okay, deal the numerators separately and deal the denominators separately. And in the denominator we have 3, 4, 5, 6, 7. So here you can see that it is increasing. So let me mark it. 10 to 9, that is minus 1, that is minus 1, that is minus 1, and that is minus 1. So there's a common difference of minus 1. Whereas for the denominator, there's a common difference of plus 1, plus 1, plus 1, and plus 1. So both of these are linear sequences. Now how to work out their nth term? So let's see. For sequence B, we have 10, 9, 8, 7, 6, right? So here for this one, we use sorry, Tn is equal to a plus n minus 1 to the power, n minus 1 times d. This is the general formula, okay, that we use for arithmetic sequences. So the first term is 10, a represents the first term, plus n minus 1, and d is minus 1 because d is the common difference, and we know that the common difference is minus 1. So if I work this out, that will be 10 minus 1 times n, that is minus n, minus 1 times minus 1, that is plus 1. So therefore this becomes 11 minus n. Okay, that is the numerator part of the sequence. Okay, what about the denominator part of the sequence? So that was 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Again, using this formula, Tn is equal to A, which is 3, plus n minus 1 times D. D is now positive 1. So this is 3 plus n minus 1. That gives us n plus 2. Okay, so therefore the numerator part of the sequence is 11 minus n, and the denominator was n plus 2. Sequence C is 4, 8, 16, 32, 64. Here you should realize that this is times 2. So each of the term is multiplied by 2. So when you have a multiplication, okay, that is a geometric sequence. Okay, so for geometric sequence, the formula that we use is Tn is equal to AR, sorry, AN R, yeah, sorry, my bad. AR to the power n minus 1. Okay, AR to the power n minus 1. So let's see. A is the first term of the sequence, which is 4. R is the common ratio. The common ratio is what you are multiplying your term with. So in our case, it is 2. So this is 2 to the power n minus 1. Now here, make sure that you don't just leave your answer in this form. Sometimes it is acceptable, sometimes it is not acceptable, right? So what you have to do is, using some algebraic manipulations related to the rules of indices, you can actually simplify it. So let's say 2 to the power n minus 1. I can write this as 2 to the power n times 2 to the power of minus 1. Okay, then I can say that this is 2 to the power of n. 2 to the power of minus 1 basically means 1 upon 2. Okay, I can, if I want to get rid of this negative power, I can take the reciprocal of this. So therefore that will give me 1 upon 2. So this 4 and 2, they will be cancelled. So this 4 becomes 2. So now you have 2 times 2 to the power of n. Now you can further simplify it, because you know that the bases are the same and the power on this 2 is actually 1. So this becomes 2 to the power n plus 1. That's your final form in which you should give your answer. All right. Question number 14. F of x is equal to 5 minus 4x. Find f of minus 3. Okay, so f of minus 3 would basically require me to substitute minus 3, okay, into x. So I'm going to write 5 minus 4 times minus 3. That will be 5 plus 12. Minus 4 times minus 3 is plus 12, which will be equal to 17. Okay. Part B, find f of 3 minus 2x. Give your answer in its simplest form. Okay. So f of 3 minus 2x means that instead of x, I'm going to substitute 3 minus 2x. So 5 minus 4 times 3 minus 2x, 5 minus 12 plus 8x. So minus 4 times minus 2x becomes positive 8x. 5 minus 12 is minus 7 plus 8x. Therefore, my answer will be 8x minus 7. Find the f inverse of x. Now, in order to write the inverse function, first you write the original function, 5 minus 4x. This is the original function. Then we're going to say that y is equal to 5 minus 4x. Now, once we have written this, okay, we swap x and y. Okay, swap them. So this becomes x is equal to 5 minus 4y. Okay, now what you do is you make y the subject of the formula. Okay, so I'm going to take minus 4y to that side, so it becomes positive 4y, and this x comes to this side, so that is 5 minus x. Divide both sides by 4, that will be 5 minus x upon 4. Okay, so now this y should be given back into this notation, so that should be f inverse of x is equal to 5 minus x over 4. So that's what your final answer is. Number 15. Virat records the height of each of 80 sunflowers. The results are shown in the table. Calculate an estimate of the mean height. Okay, so here what we can do is, when the question is about estimating the mean height, right? Because this is a grouped interval, so you don't exactly know the values. All your frequency is between. So let's say the frequency is 12. So 12 plants had height 12 sunflowers had height between 1.2 and 1.5 meters, but you don't know what the exact values are. So what you can do is you can find the midpoint, okay, of the given interval, and from that you can take that an average value in our calculations. So the first part is that I'm going to make a column of midpoint, and let's say that this is x. Okay, so let me draw the table first. The second column that I can make is of frequency, okay, and the third column that I'm going to make is of f of x. So this is your f, which is frequency, and this is f of x, which will be the multiple of frequency and the midpoint. Now, how to calculate the midpoint? Make sure that you show how you're calculating it. So for the first one, I'm going to write 1.2 plus 1.5 and divide them by 2. Okay, so we need to find the exact center of this interval. So that will be 1.35. Okay, so 1.2 plus 1.5 divided by 2, yes, that is 1.35. The frequency is 12. This is already given in the question. The second one is 1.5 and 1.6. So we know that that should be 1.55, but show it. Then the third one is 1.6 plus 1.7 upon 2. That should be 1.65. And the last one is 1.7 plus 1.9 upon 2. That will be 1.8. Write the frequencies. This is 20, this is 34, and this is 14. So the sum of frequencies is 80. Okay, that what we have worked out over here. Now if I were to work out f of x, so that should be 12 times 1.35. This will be 20 times 1.55, 34 times 1.65, and 14 times 1.8. So 12 into 1.35, that gives us 16.2. 20 into 1.55, that gives us 31. 34 into 1.65, that gives us 56.1. 14 into 1.8, that is 25.2. Sigma fx is 16.2 plus 31 plus 56.1 plus 25.2, and that gives us 128.5. Now in order to calculate mean, we will use the formula sigma fx divided by sigma f. So the sum of fx values, which is 128.5, divided by 80, and that gives us 1.60625. Now look, this is an exact answer. Okay, if the calculator gives you an exact answer, you write the whole answer. You no need to round it to two decimal places or 3 SF. No, If the calculator is giving you an exact answer, write that exact answer in its full form, unless the question asks you otherwise. Okay. All right. Now part B is draw a histogram to show the information in the table. So for the histogram, the x-axis is height, the y-axis is frequency density. So we need to first find out the values of frequency density. So frequency density has a formula: frequency divided by class width. So that is F over CW, sorry. Now, if let's say that if any of you have any confusion in remembering this formula, or you are stuck that okay, I always mix up the class width, sometimes I write class width as the numerator, frequency comes at the bottom. So in order to get rid of that, just keep in mind here frequency density is the word, right? That's what you need to find. The first word is frequency on the left hand side, on the right hand side the first word should also be frequency. That's it, just keep that in mind. Okay, so for frequency density, the first word is frequency on the left hand side. Just keep the same thing on the right hand side. Frequency should be the first word. So that's why you will always remember the frequency comes at the top. All right, so for the first one, we can say that the frequency is 12 and the class width is the difference between 1.5 and 1.2. So that will be 0.3. So I'm going to say 12 over yes 12 over 1.5 minus 1.2. So that gives us just a minute, 12 over 1.5 minus 1.2. So that is 12 divided by 0.3. So this gives us 40. Number 2, FD equals, okay, so for number 2 the frequency is 20 and class width is 1.6 minus 1.5. So that means 20 divided by 0.1, so that should be 200. Yep. Number 3, 34 and 1.6, 1.7. So 34 divided by 1.7 minus 1.6. So that should be 340. And for the fourth one, we have 14 our frequency and 1.9 minus 1.7. So 14 divided by 0.2, that should give us 70. Now we have the frequency density values. We know the intervals. Okay. The first one is 1.2 to 1.5 and the frequency density is 40. So let me mark 40 first. So 40 is over here and it should go all the way until this point. That's your first bar. The second one is frequency density is 200 and it is between 1.5 and 1.6. Okay, 200 is over here. So it should start from here and this is 1.5, so it should end over here. All right, make sure that in histograms there are no gaps between the bars. Okay, in a bar graph you leave equal spaces, but in histogram they should be joined together. Okay, number 3, that is 340 and it is between 1.6 and 1.7. So 340, this is 300, 340 is over here. So it should start from here and it should move until this point. So this is 1.7. Okay, zoom it out a bit. Okay, the last one is 14 is your sorry the frequency density is 70 and the interval is 1.7 to 1.9. Okay, so 70 is over here, so it should start from here and should go until this point. All right, so you can just avoid going outside the axis. All right, so other than that, this is how your histogram should look like. Okay, all right, so let's now move to the next one. Question number 16. The graph shows the speed of a cyclist during a journey of 30 seconds. So this is your speed time graph. Okay, so you can see that over here we have a curve until 15 seconds. Then from 15 to 25, there's a straight line. And then from 25 to 30, there's a straight line that has a negative gradient. Okay. Write down the acceleration of the cyclist between 15 seconds and 25 seconds. So between 15 to 25, you can see that the speed of the car, oh sorry, of the cyclist is a constant value. When the speed is constant, okay, the acceleration will be zero, because acceleration basically means increase in speed. But if the speed is already constant, that means there is no increase in speed, so therefore there will be no acceleration. Part B is, by drawing a tangent, find an estimate for the acceleration of the cyclist at 7.5 seconds. Okay, so we need to draw a tangent and then find an estimate for acceleration. Okay, 7.5 should be exactly between 5 and 10. So this is where we have 7.5. All right, so if I move up, so this is where I should draw my tangent. Okay, so let me take a screenshot of this. All right, so we can make a tangent over here. So that's my tangent. Okay, now I need to take two coordinates, and because I need to find the acceleration, right? Acceleration is the gradient of speed time graph. So let's see, we need two coordinates. So one of the coordinates that we can have is we can take this coordinate. Okay, but let's keep looking. We can also take this coordinate. We can take this coordinate. We can take this coordinate, this coordinate, this one, and we can also take this one. Okay, so I've marked some of the coordinates that we can take. So we are going to select any two of these. So if let's say that I take this one, okay, because it is on the y-axis, so the x value will be 0. So let's say that this is okay 4.2, 4.4, 4.6, and this is 4.8. Okay, again, how you can work that out? You can see that between 10 boxes there are 2 units being represented, so you can again do the cross multiplication and you'll find out that each box represents 0.2 units. So this will be 4.8. So we have 0 comma 4.8. That's my first coordinate. The second one can be this one. So this one is okay. Maybe we can take this one because that gives us a whole number value. So let's say I'm going to take this, and at this point, what is the time? Okay, so this is what we need to work out. So let's say this is 0. Now again, between 10 boxes there are 5 units. Okay, so that means one box represents 0.5 units. So this is zero point 0.5, then this is 1, 1.5, 2, 2.5, 3, 3.5, and 4. All right, so now these are my coordinates. So let's write them down. We have 0, 4.8, then we have 4 comma 6. Now the gradient, or you can say that acceleration, is equal to gradient, which is y2 minus y1 over x2 minus x1. So we can say 6 minus 4.8 divided by 4 minus 0. So that will be 0.3 meters per second squared. Okay, now this particular question where you're required to draw a tangent and then do calculations, this basically has a range. Okay, so let us check the marking scheme for the range. This is question number 16. Okay, so there's a range of 0.25 to 0.4. So my answer was 0.3, so that lies within the range. Okay, if you're doing this paper by yourself right now, okay, try to see what value you get by your calculation, by your straight line tangent, and then see if it lies in this region or not. If it does lie in this, and let's say you don't get 0.3 like me, still if it is within this range, then that's a correct answer. Okay, so there are two things you need to take care of. The first one is that your tangent should be exactly a 7.5. Okay, don't mess that up. Otherwise, even if you get an answer within the range, you're going to lose mark for this one. And then secondly, you should carefully choose the coordinates that are easy to deal with. Okay, that are easy to read and then do the calculations. All right, now part C is work out the average speed of the cyclist between 15 seconds and 30 seconds. All right, now the formula of average speed is average speed equals total distance traveled over total time taken. All right, now in order to find the average speed, we need to first find out that how much distance was traveled between 15 and 30 seconds. All right, so let's look at the graph. So this is 15 second and this is 30 seconds. So if I draw a straight line from here to 15, you can see that this is a trapezium. And we know that if we work out the area under the graph, that gives us the distance traveled. The area under the speed time graph tells us the distance that was covered within this region. So we know that the area of trapezium, we can say total distance equals area of trapezium, which is half into sum of parallel sides multiplied by the difference between the parallel sides. So half times, okay, A will be 30 and 15, right? So you need to find the difference. Or let's say that this is A, for instance. This is A and this is B. So this will be the difference between 25 and 15. So that is 10 plus this will be 30 minus 15, which is 15. Multiply by the height or the difference between the perpendicular height between the parallel sides. So that will be 8. So 2 and 8 they cancel out. That gives us 4. 4 times 25 will be 100 meters. So therefore, average speed is equal to 100 meters divided by the total time is 30 minus 15. So 100 divided by 15 seconds gives us 6.67 meters per second. So that's your average speed. All right, let me just drink some water. All right, so let's move to question number 17 now. The diagram shows 3 points A, B, and C on horizontal ground. The bearing of C from A is 145 degrees. Okay, it says bearing of C from A. From A means that we have to measure it clockwise from A, from point A. So this is from where we have to see and from where we have to calculate it. So this will be the angle from this until the path that will take us to point C. So that's what we mean by that. So the bearing of C from A is 145 degrees. Okay. So always look for what is written after the word from. So that is from where we have to start. An angle ACB equals to 38 degrees. AC is 65 meters, okay, and BC is 95 meters. Now look, always read the question. Do not just rely on the diagram, because look, if you only said, okay, I can see from the diagram that this is AC, so I have 65 meters, BC 95 meters, and I have this angle, you would miss this important information. All right. So therefore, always read the question, read what is given to you, and verify whether it is mentioned in the diagram or not. Find the bearing of B from C. So you need to find the bearing of B from C. So what does that mean? If I draw north at C, so I need to find the bearing of B from C. So I have to find this angle. Okay, so this is the angle that is needed because it goes all the way clockwise until this path that leads me towards B. Okay. So in order to find this angle, if I can somehow find this angle, then I can subtract 38 and this angle from 360 degrees. So that will help me in finding this angle. So if you notice that this north and this north, so both of these are parallel lines to each other. And if you look at the 145 degrees and this angle, so this is something like, let's say that we have two parallel lines. Okay, so this angle and this angle, right, this is the situation that we have. This is what we call co-interior angles. Now we know that the sum of co-interior angles equals to 180 degrees, or you can say that co-interior angles are supplementary. So the word supplementary also means that these angles add up to give you 180 degrees. So therefore this angle will be 180 minus 145 degrees, which is equal to 35 degrees. So this angle is 35 degrees. If you want if you want to make it more clear, so you can say that, let's say that this is angle x, so you can write that x is equal to 35 degrees. And then you can later on you can label it as 35 degrees as well after you have found the answer. Now what we can do is we can say that bearing is equal to 360 degrees minus, so from 360 degree I'm going to subtract x, which is 35 degrees, and 38 degrees. So that would give us 360 minus 35 minus 38, that gives us 287 degrees. All right, part B, show that AB is equal to 59.3 meters correct to one decimal place. Now, because you have to show that this is correct to one decimal place, your answer should be at a greater accuracy. We'll come on to that, but first let us see how we can calculate this. So we need to find AB. Okay, so this is what we need to find. So let's see. This is a non-right angled triangle. Okay, and within this triangle, we know two dimensions, we know an angle, but the third side is not given, right? So when we have this type of situation, we can use cosine rule. Okay, so cosine rule can be used in two scenarios. One scenario is if you have all three sides given to you and you need to find an angle, that is where we can apply cosine rule. Or you can use in a situation like this where you have two sides and one angle and you need to find the third side. So for this purpose you can also use, cosine rule. So cosine rule is cos A equals b square plus c square minus a square over 2bc. If you do not know the formula is given to you in the formula sheet over here. Okay, so this is one form of writing it. Okay, if you rearrange to make cos A the subject, okay, so we can so we get this formula that I've written here. But in our case, because we are interested in the length, right? So we can directly use the given formula, which is a square equals b square plus c square minus 2bc cos A. So we can say a square equals b square plus c square minus 2bc cos A. So this will be a is ab, okay, and I can take square root. Within that square root, I can say b square. Now this is your A. According to the formula, this is your A and this is your angle A. So B and C would be these two. So they could be anyone, right? So we can say 65 square plus 95 squared minus 2 times 65 times 95 times cos 38. Now don't just plug in everything into a calculator and then give the answer. Try to work some of the values out. So if I am to work out 65 square plus 95 square, so that should be 13,250 minus, if I just leave cos 38, because definitely this is going to give me a value in decimals, and I just work this one out. So 2 times 65 times 95, that will be 12,350 cos 38. Okay, now you can write all of this in your calculator and give the answer. Okay, the reason why I'm telling you this is because look, there are 3 marks. Okay, the intermediate working is also needed, so show some more steps as well. Now I can say square root of 13,250 minus 12,350 cos 38 equals 59.313. Okay, 313. Okay, that's enough. So now we can say therefore this is equal to 59.3 meters to 1 dp. Okay. Now part C, angle BAC is obtuse. Okay, what is BAC? This angle, this is your obtuse angle. And also now that we have found this, so it's better to label it now so we can see more clearly what data is given to us. So we can say that this is 59.3 meters. Okay, Rather, I would actually use a much accurate value for calculation purposes. So 59.313 meters. Okay, that's what I found. Now it says work out the bearing of B from A. So B from A. The bearing of B from A, if you notice, that would be starting from this, starting from A, right? So 145 degrees plus this obtuse angle. So total this combined angle would give me the bearing of B from A. So I need to find what this green angle is. Now what I can do is I have two options. I can use cosine rule, okay, because I now have three sides and I need to find this angle, or I can use sine rule as well. Okay, so what I'm going to do is I'm going to use sine rule. So we need to find this angle. So I'm going to say sine A divided by the side which is opposite to angle A is 95 equals sine 38. That is the given angle, and the side which is opposite to this angle is 59.313. All right, so now we know that sine A is equal to sine 38 divided by 59.313 times 95. You can say angle A, or you can just say that angle BAC is equal to sine inverse of sine 38 divided by 59.313 times 95. Because I have shown some intermediate working, now I can directly find my answer. So sine inverse, you have sine 38 divided by 59.313 multiplied by 95. Okay, so that gives us 80.43 degrees. Now remember, it says that angle BAC is obtuse, right? But you're getting 80.43. So the obtuse angle would be 180 minus 80.43, which is equal to 99.57. Now the last step, because we need to find the bearing. So the bearing would be, bearing of B from A will be 145 plus the obtuse angle that we just found, 99.57. Okay, so our answer is going to be 244.6 degrees. To one decimal place, I'm going to write my answer as this. Okay, do not round it off to 245 degrees, because if your answer is in angles, right, so it is better to give it to one decimal place. Okay, question number 18. Factorize 18a square minus 98. Okay, so here the only thing that is common is 2, so I can factorize 2 outside. That will be 9a square minus 98 divided by 2, that will be 49. Okay, now look, if you see closely, then 9 is actually a square number and 49 is also a square number. So 9 can be written as 3 squared, a squared, and 7 can be written as 7 squared. Sorry, 49 can be written as 7 squared. So this 3 square a square, they can be written in one bracket and we can take whole square minus 7 square. So if you remember that if we have something in this form, a square minus b square, so that is actually a plus b times a minus b. This is what we call the difference between two squares, or the difference of two squares. So therefore we can write it in this form: 2 times 3a plus 7 times 3a minus 7. Okay, and now if I open up the square bracket, so I would get 2 times 3a plus 7 times 3a minus 7. Okay, part B, expand and simplify. Okay, so first what we can do is, from these three brackets, we will only multiply the two brackets first. First we'll multiply them, expand them, and then simplify, and then later on we'll multiply the third bracket. So let's say I draw a square bracket, and I'm going to write x plus 4 times 2x minus 1, another square bracket, and then we have x minus 2. X times 2x is 2x square. Then this x times minus 1 is minus x. This 4 multiplied by 2x is plus 8x. And this 4 multiplied by minus 1 is minus 4. Again, draw the square bracket, and x minus 2 is still outside. 2x square will be written just like that. Minus x plus 8x gives us plus 7x minus 4. Now you can multiply x minus 2 with this. So 2x square multiplied by x, 2x cubed. 2x square multiplied by minus 2, minus 4x square. 2x, now 7x times x is 7x square. 7x times minus 2, minus 14x. Minus 4 times x, minus 4x. Minus 4 times minus 4 plus 8. Now simplify. Minus 4x square plus 7x square, that will be plus 3x square. Minus 14x minus 4x, that will be minus 18x plus 8. Okay, so that should be your final answer. So let me write this down. 2x cubed plus 3x square minus 18x plus 8. Question number 19. Solve the equation 2 plus cos x is equal to 0 for x between 0 degrees and 360 degrees. So this is a trigonometric equation. Okay. First of all, we will make cos x the subject of the formula. So 2 goes to the other side, becomes minus 2. Then cos x is equal to 5 divides both sides. So minus 2 upon 5. Now we will take cos inverse because we need to find x. So cos inverse of minus 2 upon 5 will give us 113.6 degrees. Okay. Now we know that between the interval of 0 to 360 degrees we can have two solutions, right? Now we need to find out what will be the second solution. So you can remember this from the ASTC diagram. Okay, now we know that our cos is negative in the second quadrant and in the third quadrant. Okay, now look, A means that all the trigonometric ratios, your sine theta, cos theta, and tan theta, they are all positive in the first quadrant. In the second quadrant, only sine theta is positive. That means tan theta and cos theta will be negative. In third quadrant, your tan theta is only positive, sine theta, cos theta are negative, and in the fourth quadrant, only cos theta is positive, whereas sine theta and tan theta are negative. Okay, now if we look over here, our cos theta or cos x in this case is negative. That means that our solutions will lie in the second quadrant, okay, and in the third quadrant. So one of the angles will be 113.6 that we have found. The second angle is going to be starting from here all the way until this part. Now we know that this is 0, this is 90 degrees, this is 180 degrees, this is 270 degrees, and this is 360. So over here, the angle always goes into in anti-clockwise direction. We always measure in anti-clockwise direction. So this goes from 0 all the way until here, that is 180. So 180 plus something, okay, 180 plus something should give us the second solution. That something is actually alpha. This alpha is the acute angle, which is this one as well as this. So this is the same. So how can we work this out? We can say that alpha is equal to 180, because this whole angle is 180. If you subtract 113.6 from it, then you will get 66.4 degrees. Okay. Uh, or what we can do is, let me use a greater accuracy over here. So let's say that this one is 578 instead of 6. We can round it off later on, but here let me use a greater accuracy, 578. So this will be 578, and over here I'm going to do the same thing, because sometimes these can cause rounding errors. Okay, so we have 66.422. All right, now what I'm going to do is my second solution, which is the blue one, that will be x equals 180 plus 66.422. So that will be 246.422 degrees. So therefore, x is equal to 113.6 degrees and 246.4 degrees. All right, that's our answer. Question number 20. A piece of metal has a volume 1240 cubic centimeter, correct to the nearest 20 centimeter. Okay, so this is your volume, and this is correct to nearest 20 centimeter cubed. The mass of the piece of metal is 7800 grams, correct to nearest 100 grams. Calculate the lower bound of the density of the metal. Okay. Now when you need to calculate any quantity that has a formula in it, okay, so the first thing is that you write the formula. Now you need to calculate the lower bound for density. In order to get the lower bound for density, your mass should have lower bound value, but your volume should have upper bound value. So that gives you the least possible density that you can have. What is the lower bound? Lower bound means the minimum possible value or the least possible value. So here what we can do is, it says nearest 20 cubic centimeter. So in order to work out the upper bound or the lower bound, first what we do is we divide 20 by 2. So that will be 10. If I want to find the upper bound of the volume, I'm going to add 10 cubic centimeters. If I'm going to find the lower bound of the volume, I'm going to subtract 10 from it. As for the mass, we have nearest 100 grams. So that 100 grams divided by 2 gives us 50 grams. So now for the mass, we need lower bound. So 7800 minus 50 divided by 1240 plus 10. So that gives us 7800 minus 50 divided by 1240 minus 10 plus 10, which is 1250. So that gives us 6.2 grams per cubic centimeter. Question number 21. OAB is a triangle. C is the midpoint of OA. Okay, C is the midpoint. So if this is the midpoint, and we can see that OC is M, so this should also be M. Okay. and CB is equal to N. All right. E lies on AB. Okay, this is E and it lies on AB, and AE ratio EB is equal to 4 ratio 5. So AE is 4. So if let's say we have a total of 9 parts, right? So let's say 4 plus 5, that is 9. Out of those 9 parts, if I divide the length AB into 9 equal parts, 4 upon 9 will go to AE and 5 upon 9 will go to EB. That's what this ratio tells us. But 4 upon 9 of what? 4 upon 9 of the length AB, or the vector AB in this case, because we are moving in this direction. Okay, we are moving from A to B, so that will be 4 upon 9 AB, and EB will be 5 upon 9 AB. Find in terms of M and N the position vector of E. Position vector is OE. Okay, so you need to find this. If I want to go from from O all the way to E, so the route that I can take is I can go from O to C, then C to A, or I can directly say O to A and then A to E. So let me write that down. OE is equal to vector OA plus vector AE. Okay, now vector OA is M plus M, so that will be 2M plus AE. We have already worked this out, which is 4 upon 9 AB. Now let's work out what is AB on the side. If I want to go from A to B directly, so I can go through an alternate path. I can go from A towards C and then from C to B. So that would be AC plus CB. Now AC is the opposite of CA. So if from C to A the vector is M, that means from A to C it will be minus M. Whereas CB, that is N. Okay, all right. Now I can write this whole thing in place of AB. So we have 2M plus 4 upon 9 times minus M plus N. So that will be 2M, sorry, minus 4 over 9M plus 4 over 9N. So 2 minus 4 upon 9 gives us 14 upon 9 M plus 4 upon 9 N. So that should be your final answer. So that is the position vector of E. Okay. Question number 22. The line y equals 4x plus 12 intersects the curve y equals 2x squared minus x minus 3 at point P and Q. Find the coordinates of P and Q. You must show all your working and give your answers correct to 2 decimal places. Okay, so we know that y is equal to 4x plus 12, and we also know that y is equal to 2x squared minus x minus 3. When these two intersect, okay, so let's say if I just draw a sketch of what the graphs should look like. So if I draw this one, y equals to 2x squared minus x minus 3. So it should look something like this. Okay, as for this one, if I draw this line, y equals to 4x plus 12, it should look something like this. Let's say, so here you can see that there are 2 points of intersection. One of them will be P, the other will be Q. They could be other around, we don't know that, right? But this is what it looks like. Now, if you look over here, for each of these equations, at the point of intersection, both the curve and the line will give you the same coordinate. They will have the same y value, they will have the same x value. Okay, so that means what I can do here is I can equate both of them. So at intersection, both the y coordinates will be the same. So I can now equate them. Okay, now let's say that if I solve this and I do get the x values, what are those x values? Basically, what I'm trying to find here is that, okay, when the y's have the same coordinate, what are the x values at these points? When two y values have the same coordinate, what is the x value on those points, right? That's what we are trying to work out here. So I can move 4x plus 12 to the other side. So this becomes 2x square minus x minus 4x goes to the other 4x goes to the other side becomes minus 4x minus 3, and 12 goes to the other side becomes minus 12 equals to 0. So we have 2x square minus 5x minus 15 equals to 0. Now look, the question tells you that you have to give your answer correct to two decimal places. That tells you that you cannot factorize this, right? Because your x values, your y values are not whole numbers. They are something which will be in decimal. So that gives you a hint that you're supposed to use the quadratic formula. So the quadratic formula is x equals minus b plus minus b square minus 4ac divided by 2a. So here I'm going to work this out. We have minus b plus minus minus 5 square minus 4a, which is 2, and c, which is minus 15. Oh, sorry. Now, how much working do you have to show? This is the first step where you have shown the substitution into the formula. You must show one more step. Minus minus plus, so this becomes 5 plus. Now try to work out the root of this entire expression. So basically work out what is the value of this entire expression. So 5 squared, that will be 25, minus 4 and minus 15, that becomes positive 60. 60 times 2, that is 20, right? So plus 120. So that will be root 145. Okay, so this gives you root 145 divided by 4. Second solution would be 5 minus root 145 upon 4. Now I'm going to work out the value to two decimal places. So we have 5 plus root 145 divided by 4. So that gives us 4.26. And when we put 5 minus root 145 upon 4, that gives us minus 1.76. Now, so we got the x coordinates. Now we need to find y coordinates. So I'm going to say that at x is equal to 4.26, y is equal to, and I can plug it into this equation, 4x plus 12. You can also plug it in this equation, but this one is easier, right? So 4x plus 12. And on this side, we know that at x is equal to minus 1.76, y is equal to 4 times minus 1.76 plus 12. So 4 times 4.26 plus 12, that gives us 29.04. And if you work minus 1.76, so that will give you 4.96. Okay, so that is your answer. So my first x coordinate is 4.26 and its corresponding y coordinate is 29.04. Second x coordinate is minus 1.76, and its corresponding y coordinate is 4.96. Okay, question number 23, and yes, this is the last question. The diagram shows the major segment of a circle, center O, radius 2.5 meters. Okay, the segment is the cross section of a tunnel with height 3 meters. The length of the tunnel is 800 meters and it has the same cross section throughout its length. Calculate the volume of the tunnel. Okay, so you have a tunnel, okay, which is a 3D figure, and its cross section is a major segment. So let's say if I were to draw a quick sketch of it. So this is your cross section, and then it extends all the way back, and then at the back you have the same cross section. Okay, not the best diagram, but you get the point, right? And maybe it's a bit like this. Yeah, that makes more sense. Okay, just one tiny adjustment. All right, so let's say if you have a car, right? So the car goes in, this is the entrance of the tunnel, it goes all the way back. The length of the tunnel is mentioned as 800 meters. Okay, and this is the exit point of the tunnel. All right, you need to calculate the volume of this tunnel. All right, it says that this cross section is consistent, it is the same throughout its length. So at every point you're going to get the same segment, the major segment. Okay, now this is a prism. Okay, you need to realize that this is what? A prism. So the volume of a prism is area of cross section multiplied by the length. What is the length? In our case, it will be 800. Okay, now I need to find out that how can I calculate the area of cross section. Okay, so let's see. We know that the radius is 2.5 meters. So that means if I draw a line over here, that is 2.5 meters. If I draw a line from, let me just draw it again from this point. All right. Also, if I draw from this center to this circumference, right? So we know that this is also 2.5 meters. So that means that this point or this height should be 0.5 meters, because the entire height is 3 meters, and if this part of the height is 2.5, then this should be 0.5 meters. Okay, if I need to find the area of this major segment, so let's say that if I complete this circle, let's say this is a complete circle, right? So what I can do is, if I can work out the angle at the center, because once I've drawn this shape, this is now a sector, right? From starting from this point till O, then from O to this point, and then this circular part. So this is a sector. If I can work out what this angle is, okay, then from this angle, I can work out this reflex angle. Once I have this reflex angle, I can work out that what the area of this part of the segment is. So basically, I can work out this area, because this is a major segment, right? So I can work out this area. Once I'm done with this, then I can also work out the area of this triangle, because if I work out this area of this triangle, so now if you notice, the brown portion and the yellow portion, they give you the complete segment. Do you get the point? Now look, these type of questions, you have to study the figure very carefully, and first you have to work out. You need to look at the bigger picture first. Once you understand, okay, this is what I have to do, then you start calculation. Don't just start calculations randomly. Okay. So I hope that that you got the picture of what we have to do. So the first step would be to find the angle at the center. Okay, let's see how we can do that. If you notice, this is a triangle, and within this triangle, this is a right angle triangle. I know this length, I know this length, so this is the hypotenuse. Okay, and I need to find this angle. This is the required angle. So I can use, this is your adjacent, this is your hypotenuse, so I can use cos theta for this purpose. Okay, let me say that this angle, this is x. Okay, so we can say cos x is equal to adjacent upon hypotenuse. So adjacent will be 0.5 and hypotenuse is going to be 2.5. So 0.5 over 2.5, x is equal to cos inverse 0.5 over 2.5. So x will be 78, 78.46 degrees. Okay, now that's just half angle, right? But if I want the angle at the center, that should be twice this angle. How can I know that this is twice the angle? Because if you look over here, this is an isosceles triangle. If this is 2.5 meters and this is 2.5 meters, the line which is perpendicular from O till this length, so that is basically that will be the perpendicular bisector of this. Okay, so therefore this angle is going to be the same as this angle. So we can say that angle at the center O is equal to 2 times 78.46. So that should give me 157 degrees. Okay, basically what I'm getting here is 156.92. So okay, let's just keep it that way. 156.92. Okay, yes, we can just keep it that way. All right, that's the angle at the center. Okay, we have found our angle. So now the reflex angle at the center, because we need to find the area of the major sector. So for that, we can find the reflex angle. Reflex angle at the center equals 360 minus 156.92, which gives us 203.08 degrees. Okay, that is this angle. 0.08 degrees. Now that I know this angle, I can find the area of this major sector. Area of major sector equals, now the formula for finding the area is theta over 360 times pi r square. So this will be 203.08 divided by 360 into pi, r is 2.5 whole square. So that would give us, all right, so this gives us 11.076 centimeter square. Oh, sorry, meter square. Okay. Now, once we have worked this out, so we are done with this portion of the we have found this area yet. Okay, now all we have to do is we need to now find the area of triangle, so that will give me the total area of this cross section. So now I can say area of triangle is equal to half AB sine C. Okay, because we don't know what the base of the triangle is, but we do know two lengths and we know the included angle, so we can find out the area using this formula. So this will be half into 2.5 into 2.5 into sine C. Your C was the angle at the center, which is 156.92. So 0.5 times 2.5 times 2.5 times sine 156.92. So this gives us 1.225 meter square. Okay, all right. Now we can say volume of the tunnel is equal to the area of cross section, right? So the area of cross section will be 11.076 plus 1.225 multiplied by the length, which was 800. So that gives us 11.076 plus 1.225 times 800 gives us 9840.8 meter cubed. Okay, so we can round this off and we can say that our volume is 9841 cubic meter. So this is a tricky question. Okay, it requires a lot of thinking. Okay, a lot of steps are needed. So I want you to now carefully pause the video and then carefully look at it, that what are the steps that were involved in this working. Okay, so let us see what is the answer in the marking scheme for this one. All right, so we have 9835 to 9844. So there's a range over here. So 9841 lies within this range. So our answer is correct. Okay. So if you want to look at the marking, so you can look at this column, which is the partial marks. Okay. So based on this, you can see how the marks distribution is done. Okay. So with that being said, this was the end of our IGCSE Mathematics paper 42 of May June 2025, February March, right? Sorry, not May June, February March 2025, paper 42. Now this was the first exam paper that was conducted after the syllabus was updated, because the syllabus has changed in 2025. So this was the first exam paper. Okay, so make sure that your concepts are rock solid. Okay, and then try to do this question by yourself. Okay, and you have the solution now. Okay, try to do this paper by yourself and then see if you have some points where you're lacking, then you can fill those gaps, revise the concepts. Okay, all right, so stay tuned for the upcoming videos, and till then, take care. Assalamu alaikum.